Hello students, welcome to video lesson 8.3b. In this video we're going to continue our discussion about trig ratios and we're going to apply them in a little bit different way. Okay, we're going to actually use what we call the inverse trig ratios, also known as inverse trig functions, to find missing angle measures in right triangles. Okay, in our last video we talked about how we can use the sine, cosine, and tangent ratios to find missing side lengths in a triangle if we know one of the angles. And in this video, we're going to talk about how can we find missing angle measures in a right triangle if we know two of the sides. Okay, so as an example, here I have a right triangle with one side length marked as 14 and the hypotenuse marked as 24, right? So they want me to find, or I'm being asked to find, this angle x right here. This is an unknown number of degrees. So I'm trying to figure out how many degrees is this angle. And for that angle that they're asking me to find, they have given me the side lengths for the opposite side all the way across and the hypotenuse. So they have given me the lengths of the opposite and the hypotenuse, right? So that's O and H. And my trig ratio for opposite and hypotenuse is the sine, some old hippie, right? So katoa, so the sine of this unknown angle x degrees here, is, as a ratio, 14/24. Now, we could reduce that down, but we don't actually need to, because in this case, I'm not really being asked to find the sine of x. I'm being actually asked to find how many degrees is the angle x, okay? So here's what I know. I know that the sine ratio for whatever angle this is equal to 14/24. Okay, I would like a way to basically go backwards and decide. I would like my calculator possibly to tell me what angle, if I put it into the sine ratio, is 14/24. What angle, if I took the sine ratio, is equal to 14/24? And the way that we do that is we do the sine inverse, okay? So the inverse sine on our calculator looks like this. It's sine and then a little -1 as like an exponent, okay? And then there's parentheses here. So I don't know if you'll be able to see, but on this calculator, right above the sine in green letters, there's a sine with a little -1, okay? And in order to get that sine inverse, I have to use the second button, okay? If I show you on this calculator, here's my sine, and then right above it in little blue letters is the sine with the -1. So then I have to hit the second button up here, second, hit that, and then I get my sine with the little -1, as we can see, okay? So what I do in order to find this angle x is I actually do the sine inverse of the fraction that I know the sine is equal to, okay? So in this case, it's going to be sine inverse of 14 divided by 24. That is going to give me x, okay? Basically, taking the sine and turning it to the sine inverse allows me to flip around the x and the fraction. Okay, so the fraction goes in the parentheses, the x is over here, and now it's a sine inverse, okay? Backwards, flipped around, sine inverse. So if I go to my calculator and I do the sine inverse of 14 divided by 24. I got to make sure that I'm in, see, I'm in radian mode currently. I need to make sure I'm in degree mode. So I flip over to degree mode. So I can quit. And I get this. I get 35.685, or about 35.7 degrees. Okay, so x in this case is about 35.7 degrees. Okay, and it just comes from doing the sine inverse of what I know the sine fraction is. Okay, a couple more examples for us. Here I have an angle x, and I'm looking for that angle. And I have been given lengths, I believe, for the adjacent side 4, right? Because my opposite would be over here. Adjacent side 4, and then my hypotenuse here is 10. So I have side lengths here for the adjacent side and the hypotenuse. AH goes with C, right? CAH. So I'm looking at the cosine of my angle x is equal to 4/10. And again, I want to know what angle, when I put it into the cosine, gives me 4 over 10, okay? Just as an aside, 4 over 10, you guys, is about 0.4. I'll show you why that's important to check our answers in just a second. So if I flip around the fraction and the x, and I switch it to cosine inverse of 4 over 10 equals x, and then I go ahead and I do the cosine inverse on my calculator, again, I have to hit the second button in the top left corner and then do the cosine inverse. So I see that -1. I do 4 divided by 10, and I get 66.42 approximately. So in this case, my x angle is 66.42 degrees. Okay, now, if I want to double check my answer and make sure I didn't do anything terribly wrong, I can go ahead and do the cosine of that answer. If I do the cosine of 66.42, what do I expect this to come out to be? It should be very close to 0.4, right? There you go, 0.400029. So that's with a little bit of round off error, it is 0.4. Okay, and that's what I wanted, is 4 over 10 or 0.4, right? One more example. And in this case, I'm actually going to have us find 2 different angles. So we're going to find x up here. We're also going to find y, because in your IXL topic at the end of the week, you have to actually find both of the missing angles in a triangle sometimes. So we'll talk about how we can do that. I'm going to start, though, with my angle x, and I'm going to figure out what side lengths have they given me for the angle x. Well, the first, the most obvious side length, I think, in a right triangle is always the hypotenuse. And recognize here they have not given me the hypotenuse, right? There is no length on the hypotenuse side. So that tells me that I must have the opposite and the adjacent, right? And I have the x, this is the opposite over here, and then this is the adjacent. Opposite and adjacent goes with tangent, TOA. So I would set up tangent of x is equal to 35 over 31. And then I can flip those around by going to tangent inverse of the fraction that I know this is the tangent. And I can say, hey, calculator, take this tangent fraction and please tell me what angle do I have to put in to get that tangent fraction, okay? So we do that again. I'm just going to do it here. We do second. Tangent inverse 35 divided by 31. And we get about 48. See, there we go. 48.468. So 48, about 48.5 degrees. Okay, so I'll just round that off to 1 decimal place. 48.46 becomes 48.5. So that's my x, okay? X is equal to 48.5 degrees. Now, once I know that, if I want to find this other angle here, there's really 2 ways I can do it. Number 1, I can set up another tangent fraction, okay? I can set up tangent for y would be 31 over 35. If you had done sine or cosine, you'd actually flip to the other one and do cosine instead of sine. But we can set up another trig ratio and find the other angle. Or I might suggest to you that it may be easier to recognize that I have a 90-degree angle here. I now know this one is 48.5 degrees. And I think I can find that one by remembering that the 3 angles in a triangle have to add up to 180, right? So I can do 180 minus 90 minus the 48.5 that I just found. And I end up with 41.5 degrees. So y in this case is equal to 41.5, okay? Now, could we also find this side length here, this hypotenuse length? Absolutely, yes, we could. A lot of different ways. We could set up sine or cosine fractions with the angles that we know now in our 31 and our 35. Or I might suggest to you that since I know the 31 and I know the 35, to find the third side of a right triangle, it's generally easier if we remember the Pythagorean theorem. We can find this, I'll just call it question mark squared, right? And we can find our side length this way. Square root that gets me about, this side length would be about 46.75, okay? So by the way, when we are given enough information to find all the angles, which we now know, and all the side lengths, which we now know, this is something called solving a triangle. Okay? So solving a triangle basically means find all angles and all side lengths. Okay, and that's what you're going to be asked to do, like I said, in your IXL topics at the end of the week. Okay, all side lengths. If you have any questions about inverse, sine, cosine, or tangent, and how we can use them to find missing angles in a right triangle, do please reach out to me and let me know. Otherwise, that's the end of section 8.3. You will do some practice tomorrow, and then we'll continue on. So like I said, if you need me, get a hold of me. Otherwise, that's all I have for you, and we will talk to you soon.